Hello, everyone. Today we're going to be talking about the quadratic formula, which is a very famous piece of mathematics, very famous formula. And if you may or may not have heard of the quadratic formula or not, but I'm going to show you guys a little bit about it and how to use it to factor quadratics. So before we see the quadratic formula and start using that, I want to talk about this property with square roots. So if you square root a number, usually we think of the answer always being positive, and we usually think of it as square root of 64 is positive 8 times positive 8. And most of the time, that's how we think of it in mathematics. But technically, the square root of a number, it could be two negative numbers, because a negative times a negative makes a positive, and a positive times a positive makes a positive. So if we have a positive answer and a positive answer, we're going to get a positive answer. If we have a negative times a negative, we're also going to get a positive. So if 64 is positive, then the square root of that could be either of these two scenarios, where it could be positive 8 or it could be negative 8. So technically, square root of 64 has two different answers. It could be negative 8 or positive 8. And they show that here. Whereas our answer could be two different numbers. So I'm going to have you guys do a couple problems with those. And you just got to realize that when you square root something, you have a positive or negative answer as an option. And that works out pretty importantly into our quadratic formula. Because with our quadratic formula, when we use our quadratic formula, I'm going to use the explanation to have it written out already. We have this formula here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you see, there's a spot in the formula where it's plus or minus because we have the square root. So we have these factors, these terms underneath the radical, and we have a plus or minus outside. That's because as the problem goes, we have to realize that the square root could have a positive answer or a negative answer. So as this goes, as you start filling in for B and for A and for C, as you start filling in these variables, we'll have to use the square root, the quadratic formula, to find out two different answers. Okay, that's because we're going to have two different roots. The quadratic formula is used to find two roots to our equation. So I'm going to use the quadratic formula on this problem, and I'll show you guys how it's kind of done. And a lot of it's plugging into this formula. This formula can be used on any type of quadratic, any of the ones that we were solving before, any of the ones coming after. Usually it's used for ones that might be a little bit more difficult. If we can quickly make a table and we can see it right away, even before we make a table, what the factors and roots will be, then we can use that. But sometimes the problems get really long, or they get answers that aren't going to be whole numbers or integers. So when we have those kind of answers, we like to use the quadratic formula because that'll always give us the answer. Whether it's a whole number or a decimal or irrational number, it doesn't matter. So first off, our equation needs to be set equal to 0. Right now it's set equal to negative 2. So we got to fix that. So we're going to have 5x plus 9x. And I'm going to take that negative 2, and I'm going to make a 0 pair and add 2 to both sides. A little bit harder to draw because it's so much smaller. So I added 2 to both sides. So now I have my equation like this. All right. The numbers that come in the front of these different terms are going to be a, b, and c. And I made a mistake. You might have already noticed it. This should be 5x squared. So it should be a squared term, a single x, and then no x's at all. So that's where we find a, b, and c, these numbers, 5, 9, and 2. Okay, even if they put them in a different order, a goes with the x squared, b goes with the x, and c is the number that doesn't have an x. So now I'm going to write down my quadratic formula. So now I have negative b plus or minus square root of b squared minus 4ac all over 2a. So I'm going to start plugging in my a, b, and c into these different parts of the equation. Okay, so I have 5 for a, so that's going to go on the bottom here, and here next to the 4 that's getting multiplied. The 9 is going to go for this negative b and the b squared, and the 2 is going to go at the very end here underneath the radical. So now I've plugged my numbers in. So I have b is negative 9, and now, or b is positive 9, so at this spot it becomes negative. Here I have 9 squared, negative 4 times 5 times 2, all over 2 times 5. So that negative 9 I'm going to leave alone for most of this problem. That'll come in a little bit later. Okay? But right now I want to simplify this sum. So I'm going to have negative 9 stay, plus and minus stay. Now under the radical, I'm going to simplify some of this. 9 squared is 81. And 4 times 5 times 2, well, 5 times 2 is 10. 10 times 4 is 40. So now I have 81 minus 40 underneath the radical. On the bottom, 2 times 5 is 10. Now I'll go from here and simplify a little bit more. I have plus or minus under the square root is 81 minus 40, which is going to be 41. And you might realize off the top of your head that that is not a perfect square. So that means that this radical is not going to be a perfect square. It's not going to be a whole number or an integer. So what I'm going to do is use Google to find out the square root of 41. It's going to be 6.403. And normally I would want to use the square root, and I wouldn't want to simplify it into just a decimal estimation. But depending on what I want to do with the problem, I could leave it in terms of this, to leave it in the terms of the radical without estimating. But I'm going to want to estimate a little bit here. So I have 6.403. I'm pretty sure that Alex normally wants us to round to the 100th place. So that 3 is not big enough to round the 0 up. So it'll be 6.40 or the same as just 6.4. Yeah, nearest 100th place. All right, so now this is going to turn into, I'm going to draw a little arrow and take it up here. Negative 9 plus or minus 6.4 all over 10. So now this is where it switches into two different types of problems. All right, so I'm going to have negative 9 over 10, and 6.4 is going to be there. The numbers don't change. It's this sign. We have either a plus or a minus. So I'm going to do one with a plus. I'm going to do the same thing over here on the right, but instead of with a plus, you guessed it, it's going to be with a minus. So now I have negative 9 plus 6.4 over 10 and negative 9 minus 6.4 over 10. So negative 9 minus 6.4. I don't have my graphing calculator, but I'm going to need to use that. So I'm just going to use it real quick on my phone. Negative 9 minus 6.4. It's going to be negative 15.4 now over 10. And negative 9 plus 6.4 is going to be negative, whoa, there's a big negative, 2.6 over 10. Okay, I'll divide both of these, and I'll get negative 0.26, and I'll get negative 1.54. So now these are my two answers. These are the two roots that I have in this problem. So if I look at my explanation, they should have these down here. Oh, good. We estimated the same way, negative 0.26 and negative 1.54. So I'm going to leave this and I'm going to go to decimals. And what I'm going to do is I'm going to put in that equation. So we had 5x squared, this is hard to read, let's do that. 5x squared plus 9x plus 2. So over here I put in 5x squared plus 9 x plus 2. Now we have this parabola, right? So we already knew that this is going to make a parabola on the graph, and you can see these different spots of where they connect. Well, let's see. Looks like Desmos also is estimating to those decimal places. And if I take a look, our roots, where they cross the x-axis, are at these two different points. The 2 points that we found, negative 0.26, negative 1.54. With a quadratic equation, we need to use that on ones that don't necessarily find the graph in nice even spots. If I put in this blue quadratic equation, it's going to come through our graph, and it's actually going to come through in very nice even whole integer sections. Okay, the quadratic formula can show us and get us these two answers as well, but it's not as necessary as the problem where we have these decimals, these hard to find spots on the graph. So the quadratic formula can be used on either of these, but it's so much more helpful on these ones where we can't make a table to try to find out different spots of what decimal expansion is going to give us this times this and make a table that also adds up to this different amount. It's going to be a lot harder. Okay, quadratic formula is a go-to. And there's sometimes I look at these equations and maybe I see that it's going to be negative 2 and negative 8 right away. Sometimes I might not see that right away. And I just say, you know what? I don't know what it's going to be. I'm just going to go with the quadratic formula and it'll give me my answers no matter what happens. So with these problems, you're using the quadratic formula, this formula, and you're going to be plugging in A, B, and C into those different locations. You're going to be simplifying, and once you get everything simplified under the radical, then it's going to split into two different problems, where you add in the middle or where you subtract. Okay, and that'll give you two different roots. Now, something I want to show you is what's called the discriminant. The discriminant is a small section of the quadratic equation. So with the discriminant, it shows us and gives us a little bit of information. We have this quadratic equation, and the discriminant, here we go. The discriminant is b squared minus 4ac. So the discriminant is what's underneath the radical in this section of the quadratic formula. The formula is the whole thing, but the discriminant is just this small section. So the discriminant tells us a little bit of information. Okay? It's about how many solutions or what this, if there's real solutions or not real solutions. So if we have b squared minus 4ac, if what's underneath the radical is larger than 0, then there's going to be two real solutions. Okay. In the last problem, we had 6.4. Okay. That was larger than 0, and there were two solutions. We had two negative numbers, negative 0.24 and negative 1.54. Those are the two real solutions we had. If underneath the radical it makes exactly 0, then we're only going to have one real solution. And that means that the graph comes through and the x-axis is right at the vertex of our parabola. So just barely touches it and goes up for this option. If it was the first option, that's where the graph comes through and you have two different solutions. And this last one, I'm going to put in red here. If the discriminant is less than 0, then there's no real solutions, which means my graph, whether it's vertical or horizontal, or if it's up or down, it's going to come up like this, and it's not going to touch our graph at all. It's going to be a little bit too high, or could be upside down to where it could be like this. It never reaches the intercept, or never reaches the x-intercept. So it doesn't have one, doesn't have any roots, which means here we can see that as we're doing the quadratic formula. So you might want to look and see if the answer is no real solutions, then as you're simplifying this, you don't have to do those last couple steps. You already can see, oh, there's no real solutions. That's my answer. Moving on. You're save yourself a little bit of time. But if you come through and you see that 0 is going to be there, you know it's only going to be one solution. And if the number is anything greater than 0, then you'll have different solutions to go off of, and you'll have 2. Okay? So what these problems want you to do is they want you to use the quadratic formula. They want you to take this, plug it into the quadratic formula, but they're just looking for the discriminant. So you don't necessarily need all the rest of it. You just need what's underneath the radical. And if you see b squared minus 4ac, that's all they're using here on this explanation. And so they took what's under the radical and they replaced. -2 goes for a, 6 goes for b, and 5 goes for c. So now 6 squared minus 4 times -2 times 5. 6 squared is 36. -4 and -2 will make a positive number. Oh, they didn't show that yet. They kept the two negatives. Then 4 times 2 is 8. 8 times 5 is 40. These two negatives make a positive, and so you'll add them to make 76. So the discriminant is 76, which is greater than 0. So we have two real solutions. And that's what they want you to do on this problem. When they're just asking for the discriminant, you only have to do this section of the quadratic formula and write down how many solutions there are. And this last one, I'm going to give you a real-world solution or a real-world problem to use for the quadratic equation. And a lot of times it's different areas of life where there might be a parabola. A lot of times you see them as throwing something in the air. So it depends on what it is. Looks like they threw a ball in the air and they have this equation for it. And so they want to know what the ball's height is at 23 feet. So what this means is that this ball, they kind of have a drawing here. I'm going to draw a little bit more. This ball is going to have this arc. Okay, it's going to go up. It's going to get higher and higher and higher. And then eventually gravity is going to kick in and it's going to stop getting higher and start getting lower and then come back down to the ground. All right. So what they want to know is what the ball's height is at 23. So they're going to say, let's say 23 feet is right here. They want to know what the height is going to be at 23 feet. Well, depends on the ball and how high you throw it up and all that stuff. It might reach 23 feet right here at this time, or as it comes back down, it's going to reach 23 again at this time. Maybe this is 5 seconds and maybe over here, this is at 8 seconds. Or possibly it could be at like 72 seconds or 72.749 seconds. It could be at a lot of different spots. And depending on our parabola and what height they ask, if they're asking for 23 feet, maybe it's there. But what if they ask for 26 feet? Maybe 26 feet is right up here. And so it's not going to have two different answers. It's only going to have one place where it touches. Or what if they ask for the height at 29 feet? Well, 29 feet is up here, and it's never going to reach that. That's where the discriminant will come in. You might be able to see how many solutions it has. Does it have 0, 1, or 2? Most of these are probably going to have 2 solutions. And I didn't do the math, so I don't know if any of these numbers are correct. But we can use the quadratic formula to find that. Looks like when they wrote this equation, I don't know if they're going to write it the same way for all of these, but they kind of wrote it backwards. Okay, remember, A goes with the variable squared, B is with the single variable, so the variable to the first power, and C is where there's no variable at all. So that you could think of that as the same as the variable to the 0 power, 2, 1, 0. Even though they wrote it backwards, A, B, and C still have to match up the same way. So if I look at their explanation, let me see if I can erase all that. Nope, just the red. I don't know how that eraser works. So if I look they took this, they set it equal to 23 for the height that we're looking for, not any of these other ones, but 23, okay? And so then when they do that, 23, we'll solve it for 0, because that's what we want our roots for 0. When we set it equal to 23, it's almost like making 23 the x-axis. That's what we want to look for, is the x-axis, all right, when it's 0. But we have to use 23 to get there. So put it for 23, then they evened it all out, put it in the order, and got set it equal to 0, okay? And use the quadratic formula, plugging in all these numbers, simplifying to this spot, and then this is where it breaks off into two different problems. So where it's subtraction or addition. And after you put that into the calculator, simplify that, you'll get this answer or this answer. And so you have two different spots. And so, sorry, my drawings are all in the way. It looks like it'll be at 0.86 seconds or 1.45 seconds, right? And you'll have these two answers.